This is TechSNAP, episode 390. Hello and welcome to TechSNAP, Jupiter Broadcasting's weekly systems, network, and administration podcast. This episode was recorded on November 21st, 2018. My name is Wes, and joining me back from gallivanting around the globe, it's Mr. Chris Fisher.
Hello, Wes. It's good to be back and solving problems this week in a Wireguard special. In fact, in spirit, Jim will be returning just a little bit as we get into Wireguard, and a big thank you to Jim.
No kidding.
He stood in last week and just a bang-up job. Did a great job.
Now, Chris, if you're like me, over the years, you've had a ton of different VPN solutions, IPsec, PPTP if you still live in the dark ages, and of course the ubiquitous OpenVPN.
Heck yeah.
None of those are a ton of fun to use, and recently there's been a new kid on the block. Enter Wireguard.
Oh yeah, I've been seeing a lot about Wireguard. We've kind of discussed it back and forth on this show, but really if you've been following the news, been following Linux development, or just a big fan of VPN and networking technology, you've probably been hearing Wireguard thrown around a lot, but I think there's confusion as to what it really is.
Yeah, it's one of these technologies that's kind of in the middle of the stack, and you can use it for a lot of things, so it might not be clear just what it is at its core. And really, at its core, all Wireguard does is create an interface from one computer to another. It doesn't let you access other computers on the other end. It doesn't forward all your traffic through the VPN server or anything like that. Really, at your base configuration, it just sets up a new network on top that connects two IP addresses.
This is some low-level stuff, and I think we need to do a TechSNAP deep dive into Wireguard, and it's something that we're considering utilizing ourselves for our day-to-day operations, and we thought, geez, if we're looking into it, maybe it's time to talk about it for the audience, too.
Well, it's probably best to start with some basics here, and if you've used OpenVPN, you're probably used to this whole user space VPN solution. You know, you get like a ton or a tap device provided by the kernel, and then the OpenVPN program that you run connects and talks to it. Wireguard, well, in its main form, it's a little bit different, and that's because the end goal is to be integrated into the Linux kernel.
Yeah, obviously that'll give you some great performance, and to that end, certain Linux developers are quite interested in seeing that happen.
Unfortunately, Wireguard didn't make it into the most recent kernel. That's right, you won't be seeing it in kernel 4.20, but the code continues to be worked on and improved upon. And really, I mean, I think there's a lot of goodwill towards this project in the kernel community. There has been some, part of the contribution of Wireguard included a bunch of refinements and basically a new crypto API implemented in the kernel. That's been kind of the biggest slow point, is figuring out what the right abstractions are. How do we make that fit in the kernel that we already have? But I think the end goal is not only will we get a new, really great VPN solution right in the kernel, but we'll have some nice crypto primitives that other applications, other kernel developers can then use.
That is exciting. And just because it isn't in the mainline kernel yet, it doesn't mean you can't get your hands on Wireguard and play with it today. There are methods.
Oh, yes, absolutely. So there's multiple user space implementations out there, or if you're already using a Linux system, it's just a kernel module. Seriously, like there's PPAs, there's Copper repos if you're on a DNF-based system. It's not hard, the source is small, and that's one of the things people really like about Wireguard. It's small, it's lean, it's a fresh implementation. The author has some great presentations with some charts that show you just how much smaller it is, and part of that is a reduced scope, right? It's not an all-in-one VPN solution. It's not going to magically make you this giant mesh network, but it's secure, it's easy to audit. There's been some preliminary audits, and so far it looks really good. It's all modern, trusted crypto, and it really only uses algorithms that we know are good today.
Yeah, and we're going to bring Jim back here in just a moment, and he'll talk to the speed of the thing, which is a bit of a game changer when you hear about some of that. So it's really checking all of the boxes for mobile broadcast production, where we need to get access to our mixer control and some of our hardware devices that were really never built to be controlled over the internet. They were only ever built for LAN control. But with internet connection speeds as good as they are, like when we're at the Linux Academy office, we can fully remotely control a lot of our hardware, and the actual dials in the studio move.
Oh, it's a lot of fun to look at.
It's really cool. But you need a fundamental connectivity. You can't just connect over a public IP to it. So we've been looking at implementing Wireguard. It's sort of a low level where our laptops would be connected back to the studio. And to that end, Wes recently gave it a go installing it on a Fedora system. And so here we go. Perfect example. Wasn't in the mainline kernel. How was the process of getting it installed and setting up a WireGuard server?
Oh, it was super simple. There's a PPA if you're on a Debian system, or there's various methods to go get it. You can compile the source if you need to. It's really pretty lean. It makes a small module. It's not that painful VirtualBox DKMS experience where you're waiting 10 minutes for your module to compile and causing all kinds of problems. No,
True. It's only 4,000 lines of code or whatever.
It's tiny and it's easy. And then it also comes with just a little bit of a user space helper program. There's a couple things. There's the basic WG command, and that has all the primitives that you might need. And there's a WG-quick, which you can look at it. It's a small bash script. Like you can just read it, you can modify it, you can fork it, do whatever you need to it. That handles some of the additional niceties that you might want if you're used to a more full-featured VPN solution.
So when you have this all installed and you have it configured, the sign of a successful connection is you all of a sudden have a new interface?
And that's kind of one of the neat things is it really integrates into the existing functionality. So, the IP command, you go IP link, you add a new link type, and the type is just WireGuard. So then you usually get you'll start with probably WG0, and that'll be your first WireGuard interface. And then you sign, so you do have to do some things like pick what IP address space you're going to use, right? So you'll probably assign just like a /24 or something. You can do smaller if you just have 2 peers, but 24s are a pretty common size people are used to. So assign that, get your address set, you can bring it up, and then there's a couple WireGuard specific things, but it's really simple. It reminds me a lot of SSH because rather than a really complicated TLS style, if you've ever set up OpenVPN and you start using easy RSA and you're generating all these keys and you have this complicated trust setup. Not so with WireGuard. It's usually on your server, you go generate a private key, and then using that private key, you can generate a public key and go share that. You also need to know the endpoint that you're trying to connect to. So whatever your public IP address is for the droplet or whatever system that you're running. From there, you just use the WG command and you say okay, well, here's the private key you should use. And then here's the you can tell it what port to use to talk WireGuard on, and then you add things about the peers that you want. So you're okay, well, here's the peer I'm going to connect to, or here's all the peers I know that I want to connect to me. You can do things say only allow those peers to connect from these IP address ranges. Then you provide the public key of those peers. After that, you're done. And you can do it all in the command line, or they have a pretty simple sort of systemd-ish, ini-ish configuration file that you can use. And then you just say hey, WireGuard, use this configuration file for this WireGuard interface. You're done.
The configuration, I did have a chance to go through it. I didn't set up a server, but I went through a config file, and it looked really straightforward. It's very easy to just read and understand, having never used WireGuard before.
So you will still need to do a little bit of key exchange, right? You just can't. You can't get around that.
Those helper tools, though, to generate the public key for you make it a lot easier.
It really is. You and I, if you have a secure chat channel with someone on whatever platform, we just exchange public keys just like we do with SSH or GPG or anything else that's modern crypto based. And then I just have to know your IP address or whatever, depending on your topology that you have. And then you just say IP link up WG0. And you should be able to ping the other side.
The reality is once this thing is mainline and more people start using it, there will be probably even graphical tools built into desktop environments to make this really easy. Import the key, set up a connection, good to go.
Yeah, right. I mean, probably there's lots of times where you can just have it, generate you a key automatically. Here's your user key for this workstation. Here's your public key, copy it. Here you can easily share it with a QR code or whatever else.
So the other thing that it seems to me is that with it being as low level as it is that WireGuard would be a really good candidate for persistent remote encrypted connections.
And it works really well. The way it detects connections is really very clever. And so you don't have to have this complicated setup. Have you ever torn down and then reset up an OpenVPN connection? It takes a while, 30 seconds sometimes. You have to struggle. You're okay, is it going to connect it? With this, there's no failures. Once you've got your WireGuard interface up, just go send traffic. And that's where the magic happens. Once it hits the kernel, once it starts processing, it figures out based on those allowed IPs, okay, can I send to this based on this setup? And then it encrypts it and sends it over. And if you've already got that tunnel established, like today, I was doing some tests this morning, had it all working at my house, drove up here to the studio. When I popped on the studio network, boom, pings right there.
Really?
No problem.
So you change IPs?
Yes, it's very good at roaming. So it's
great.
one of those perfect things where if you have a trusted connection somewhere, not only if you wanted to get access to a LAN network, but if you just want to, you're at the coffee shop, you just don't trust what's going on there, WireGuard makes that very easy.
We've recently seen several attempts at mobile apps to support WireGuard. That must be one of the reasons why NordVPN, a commercial solution, is introducing WireGuard support for their VPN service. It's probably a great candidate for people that want to protect data on their mobile devices in transit.
And the author has done a good job, too, of making that really easily available. There's work in progress, for example, on a kernel support for FreeBSD, but in the meantime, you can just use the user space implementation, and that's a lot of the same stuff that's being used on the beta iOS app or the Android app or on any system that doesn't have a kernel module.
All right, well, co-host of the show last week, Jim Salter, is also a writer over at Ars Technica, and he posted a nice, long, great in-depth review of WireGuard. He's pretty passionate about it. In fact, he's so passionate that you and him just sort of in a side hole just started talking about WireGuard, and we thought, let's use that for the show. So we saved the clip, and we're going to play it for you this week.
You wrote a great piece on it for Ars. I'm wondering, what are your thoughts? Have you been using it in your personal life, and do you plan to?
I have. I am in the process of switching over a pretty large OpenVPN mesh network that I use for monitoring for client sites. I'm in the process of switching that largely over to WireGuard. I don't really trust the third-party Windows implementation that's out there.
Oh, yeah.
I don't really trust that, so I'm not going to be able to replace the OpenVPN connections on my Windows virtual machines. But my infrastructure is all based on, you mentioned it earlier, Sanoid. My ZFS and KVM based tool. And I want to be able to monitor all those Sanoid hosts, and those are all Linux boxes, so I can install WireGuard on those. And the way things started out is I have, outbound, I mentioned before, the right way to do these things where you want connection across NAT is you push the connection out from inside and you connect to the data center, right? Well, I'm doing exactly that for my monitoring network. I've got Nagios and I've got an OpenVPN server out there in the cloud. And, I've got a few hundred machines that I'm monitoring that all punch out of their networks through NAT. They initiate a connection to that OpenVPN server. And then from there, from a trusted network, I can monitor all of them. I can use Nagios. I can get shells on them if I want to do maintenance, whatever. The thing is that it's been really aggravating to maintain because OpenVPN likes to just randomly crash or lock up the connection, and it's a giant pain.
It just does that all the time. You can't have one up for more than like a couple days a week before that happens.
Yeah, and despite the fact that there are arguments in the OpenVPN configs that are supposed to deal with exactly this problem. You've got keep alive ping, you've got keep alive restarts that are supposed to automatically restart the tunnel if they don't receive pings after a certain amount of time. But the crap just doesn't work, even with all that in place. With a few hundred machines I'm monitoring, basically 5 to 10 a week are dropping out and locking up, and I'm having to go through and basically grab them by the neck and shake them. I've written a whole bunch of my own external watchdog scripts to try to throw their own pings down the tunnel and deal with it if the tunnel locks up, but sometimes OpenVPN actually crashes and the process is gone. Sometimes it just locks up and the process is there, but you can't get any data in and out of it. And if you would think that you just go, etc init.d, OpenVPN restart, but sometimes the old process is still there and it will restart, but then you end up with 2 processes that are supposed to be doing the same tunnel, and then eventually you end up with 50. So I've had to go through and just the logic in trying to make my own watchdogs to deal with all this has just been a nightmare. So far, I don't know if you could hear that. I just knocked on my desk there, knock on wood. I haven't seen any kind of flakiness or goofiness from WireGuard, where an OpenVPN tunnel tends to establish within somewhere between like 8 and 32 seconds. WireGuard tunnels establish in about 120 milliseconds. So basically, by the time you're hitting enter from saying WG quick up WG0, basically by the time you've hit enter, it's pretty much connected right then.
Wow, that's a great user experience. What do you think of the admin side? Because sometimes OpenVPN, once you're familiar, it's fine, but I think it's kind of a hurdle for people. I'm wondering if WireGuard's going to be easier for competent people, but who are new to the VPN space.
Well, so being honest here, it's still a VPN. It's still not really easy in an absolute sense. Mm-hmm. With that said, it is tremendously simpler than OpenVPN. I made the comparison in my Ars Technica article when I first got started with OpenVPN, I knew that I needed to build a VPN, and I had plenty of time to devote to it. And I spent pretty much a week, doing nothing but burying myself in OpenVPN and setting things up and tearing them down and testing and figuring out what I needed to do. And at the end of basically a full-time week, I was able to do that. By contrast, with WireGuard, I saw the email on the Linux kernel mailing list where Linus Torvalds said, can I just say I love WireGuard and I want to see it in the kernel soon?
Right.
I was like, okay, I need to sit down and play with this now. Well, that was on a Sunday afternoon, right? And my wife was off at a Moms Demand Action rally, and I was alone with my 3 kids. I've got a 9-year-old, an 8-year-old, and a 5-year-old.
So it was fair to say you were probably a bit distracted at times.
Yes, and I just sat and I'm like, okay, let's get started playing with this. And at the end of that afternoon, I don't remember, like 4 or 5 hours, while I'm watching my 3 kids, I had not only managed to get WireGuard working, I had gotten 3 different configurations working, starting out from the simplest, I just want to make a connection and throw data over it, to, okay, now I want a working, internet gateway with NAT and Masquerade where all my traffic will go out, through the tunnel over an untrusted network. And then finally to a more complex setup where I had multiple WireGuard NICs on the same machine with, one as, like an untrusted and one as a trusted, and the untrusted weren't allowed to talk to each other or anything else. The trusted network would be able to then, bridge the 2 interfaces and go down and get a shell on any of the machines on the untrusted side, basically re-implementing, my monitoring network that I described earlier. Well, I got all that done in a few hours while I was watching 3 kids.
Wow.
So that's a huge difference from OpenVPN.
That is a great testament. And, it's nice to have that simplicity. I love the integration. It feels very natural, especially on Linux. Now, you did mention a good point. There are various userland implementations that are official, but there's nothing for Windows yet. I did see, though, the project says, in theory, that is in works, right?
Yeah, Jason's working on it, and it should be awesome once he finally gets it done. I'm not sure where it sits in his priority list. I know he's a busy guy, and he's doing an awful lot of stuff, but the big thing that I'm really excited about for the Windows native WireGuard implementation is it's going to do away with the tap adapter.
Oh,
if you do OpenVPN on Windows, you use that open tap adapter.
Right.
And on top of OpenVPN's own bugs, the Windows tap adapter is a nightmare. The OpenVPN dev community blames it on DHCP bugs in Windows, but a lot of the time, the open tap adapter will not successfully get an IP address, or it won't get one of the pushed configurations like a DNS server or whatever coming from the OpenVPN server. And you end up having to go through and you got to do stuff like you got to go to your network connections and find the tap adapter and right click it and disable it and then re-enable it and then start the VPN connection again. And then hopefully you'll get the IP address. It's a pain in the butt.
That's annoying enough for you, a senior admin, but like then for clients, right? People are just I'm just trying to connect so I can watch this presentation or get my work done. Yeah,
they're basically not going to do that. I mean, they need me for that. It's a pain in my butt because I got to go through and I got to do that for them. Because I mean, the 20th time that you've been through that, you might get somebody that's like, oh, well, let me go to, start typing control panel and here comes control panel and go to, internet options and get from there network connections and local adapters and then find the tap adapter and then right click it and disable it and then right click it and re-enable it and then try. But I mean, that's a pretty advanced user and you've had to do that several times before they get that workflow in their head.
I mean, I'm exhausted just hearing you say all of that. I'm ready for a nap.
But yeah, WireGuard will not use that. WireGuard is actually going to, Windows has an API for VPNs, and WireGuard, Jason Donenfeld's implementation of WireGuard for Windows is going to use the Windows VPN API, which means it will actually get a native Windows virtual network interface. And it means that you will manipulate, or at least you can manipulate WireGuard on Windows once that's done, using the exact same interface that people are already familiar with for corporate style VPNs, the less secure PPTP and L2P VPNs that are like built into Windows. There are an awful lot of people that I personally don't find that interface very compelling, but there are a lot of people that already have that like drilled into their heads. They feel comfortable with it because it looks like Windows, and
Right.
they'll be able to use all of that with WireGuard and have actual native Windows virtual NICs that won't have this whole plague of extra bugs with them. So I'm pretty excited about that.
So we should get better support. It should be easier. Hopefully it'll be a little more palatable to Windows admins who maybe, not liked all that, the open tap stuff. That maybe one day we'll actually have a future where, people will run WireGuard in their daily lives and it won't be a big deal.
Hopefully so. In a way, there's kind of a shelf life on all this stuff, because the whole concept of a VPN is like, okay, I need to establish this encrypted tunnel to put all of this, yucky, squishy traffic that I'm worried about somebody being able to man in the middle, right? But meanwhile, everybody's busy, adding encryption to literally everything, native in the protocol and in the connections between two devices. Like if you're doing HTTPS traffic, and if you're already doing TLS encrypted DNS queries, like there's not a whole lot of point in encapsulating that in a VPN, right? Don't get me wrong. It's not like I'm saying we're going to wake up tomorrow and not need VPNs because everything will always talk encrypted to anything else. But I think that's going to be coming at some point.
Yeah, we've seen some moves, right? Like what was Google's effort Beyond Corp, where services that they provide are more designed to know that they exist on the internet, that there's authentication stuff built in instead of the old school enterprise model of everyone on the internal network is trusted and you can VPN in and then everything on the outside is untrusted.
Yeah, and just we've learned anytime you've got, plain text traffic, you've got a serious problem. And you start out thinking, oh, well, I can trust anybody inside my building. Well, really? What about when your building has, 10,000 people in it and you don't know who's on the Wi-Fi? It gets to be, it's a lot easier just to make sure that everything is, encrypted with its own, point-to-point connection to begin with. And like I said, we're already seeing that shift to everything. We're seeing more and more things running over HTTPS. We're seeing, SMTP connections running over TLS. You name it.
DNS is a big one that we're slowly working on, slowly
getting there. And, that bridges over into, I sometimes end up evaluating devices in the consumer space that promise to protect your home network by, shielding you from the connections that your device might make to, a malware site or a phishing site or whatever. And, I always kind of have to bite my tongue because, I'm looking over these things and some of them are okay. Some of them are a very valuable additional layer. None of them are a magic bullet. If anybody says, throw away your antivirus, this router's got you covered, hide your wallet. But again, there's a shelf life on all this because basically once DNS is encrypted always and by default, there's not much left that a router in the middle that you trust can do for you.
That's a really great point. Once we slowly lift encryption, apply it to everything, actually have secure implementations on top of the internet, once all of our connections and standards are using that, well, that'll be a better world and we can be a little less paranoid, not totally unparanoid, but we'll know we have that baked in. We don't have to add an additional layer for ourselves.
Well, yes and no. There's pros and cons. Because like I said, the good thing is all your traffic's encrypted and you don't have to worry about a man in the middle. The bad thing is, you've got a house that's full of, we fast forward to when DNS is encrypted by default. We give that at least 5 years and more likely 10, right? Well, a typical household has already frequently got 20 plus internet connected devices.
Yeah.
Wired or Wi-Fi, Internet of Things, your set-top box, that you get your, your Netflix, your Hulu or whatever through, your computers, your phones, your tablets, sometimes now, drones, you name it. There's all kinds of stuff. That's only going to be even more the case in 5 or 10 years once we imagine that DNS is probably going to be encrypted point to point straight between the device and, whatever it's trying to connect to on the other end, right? Well, once everything is connected, now if you, as the person who, whether you like it or not, you're in the role of saying, I'm the network admin for this house full of 20, 50, 100 devices, I want to make sure they all stay safe. Well, you can't because you're the man in the middle. And that man in the middle can't do anything because each one of those devices, it's the god of its own little realm.
Yep, that's a great point, right? Like when you hard code your own DNS, that's one example you see a lot with devices these days. You can't change that. Even if you push a DHCP option, well, it's never going to respect it. So you're out of luck. And that's a really good point because as we see more of this, well, they're going to do it on their own and you won't have any control.
Yeah. And when your malware site is just sitting somewhere on Google Cloud and it may not even have a static IP address, it basically comes from wherever happens to be hosting that service, on an app engine right now,
Right.
it's going to get really hard to filter that kind of thing. And if you don't have access to the DNS, then you don't really have any way as a trusted man in the middle to shield other devices from that. Now you're having to trust each one of those devices individually to do sane and smart things, and you've kind of shifted yourself into an entirely new problem space.
Thank you for going to techsnap.systems/contact to send us your questions, feedback, and of course, those war stories. Just like Cody did.
Yeah, Cody writes in, he says, "Hi, Chris and Wes. I know you guys don't normally cover networking topics, but I think your TechSNAP listeners might like this." Well, hold on.
Yeah, I think we have to question that a little.
I mean, I think we cover networking topics quite a bit, to be honest with you. Like, I hate to disagree with somebody who took the time to write us, but
it is right there in the snap. It's part of the snap.
Perhaps we should just do more.
I think that's what Cody's trying to tell us.
He says, but hopefully I can pass on a few links that will make networking more accessible to people wanting to learn. First of all, that's awesome. labs.networkingreliability.engineering is one, and anti.project.readthedocs.io is the other. We will throw links to these in the show notes, don't worry. For those that are looking for orchestration, if you didn't come across StackStorm, then I would recommend checking it out on GitHub and their integration packs. Written in Python, and it can run scripts of any sort to return data to perform the next job, which is super handy. So think about that for a second. It can retrieve information, store it, and then pass that information on to the next job. That is great. And then it also has a built-in UI for interaction. And he has links to that, and he says, "Happy automations to all." Well, thank you, Cody. Great links. We'll try to toss those in the show notes at techsnap.system/390.
Really, thank you, Cody. These are all great links, and I hadn't heard of any of these. NRE Labs is this really neat little online interactive place you can go just play around. If especially when you're learning networking, it can be hard to know how to set everything you need to get a lab going that you can actually play around with because you haven't learned it yet. Hopefully this goes a long way to fixing that. Also, I think it's Antidote Project, although I like Anti-Dot.
Oh, you're right. Oh my gosh. Overall, I thought I did pretty good on that email, but I definitely thought I was getting a little into the weeds when I was reading the URLs. Oh, well.
And that one looks fun, too, because it teaches from-scratch network automation skills for network reliability engineers.
Cool.
And then also, I think we would be interested in his other suggestion, which was StackStorm.
Yeah.
And if we were a little bit bigger, this looks like Huggin on steroids.
Oh.
Like if you've got a complicated CI system, you've got multiple asynchronous inputs and events that you want to have, StackStorm looks like the way to go.
You might have just heard Mr. Payne name drop Huggin, which is probably actually not pronounced that. It's Hugin, what was it?
Yeah, I think so. But we've decided we just like hugs over here.
This is a really cool system that you might look into to have anything that you want essentially be event-driven, like an automation script or a process, some file transfers, some maybe renaming. There's all kinds of things. Think of your own if this, then that self-hosted service on your LAN. We did a full breakdown of what we're using it for at Jupiter Broadcasting in Linux Unplugged 274. If you want to watch that episode or listen to it and then get a sense of how you could use it, it's pretty powerful, and it's not intimidating either. It's got quite a bit of capabilities, quite a bit of flexibility, but it's not going to scare you away. Check out linuxunplugged.com/274. That was a great find. It was a great find. And thank you, to Cody for sending in your emails. Thanks to everybody out there for going to techsnap.system/contact and sending in, I'm going to say, war stories.
Yeah, we love war stories. It's a great time.
Let's do the war stories.
Now if you're spending any time with family or just taking some time off, reflect on those dark times and share that. It's always cathartic.
I wonder if there is anything with a Thanksgiving theme, like a war story with like a Turkey Day theme to it. That would go to the top.
Yeah, those
of the
worst times you got called, you got paged right in the middle of Thanksgiving dinner. We would love to hear about it. Well, that brings us to the end of today's episode. But before we go, some final thoughts.
You almost sound a little resigned, like you're not ready to go yet.
I'm not. There's too much good stuff to talk about.
Yeah, in fact, a note on that point. We are approaching the holiday season, and Wes and I also have some more travel coming up. We will attempt to not miss a week, but it may happen. So never fear. Just go to techsnap.system/subscribe. If we miss a week or two, we're not gone. We're just in the middle of holidays and travel, but also as we begin to approach episode 400,
It's a big time for the program.
we're beginning to consider some creative improvements. The TechSNAP program was built, engineered, grown during a time when the network was advertiser funded. But the reality is that's no longer the case. We now have Linux Academy that is completely funding our operation. And so there's certain things that we built into the show to accommodate advertisers that we no longer need to do. And we also want to take some of that funding we have with Linux Academy to even increase the quality of the content that we put into the show, expand the scope of it. You may have seen we've been working to that end already. Some of these things that have been happening while I've been traveling are experiments in that direction. Wes, you've been doing great.
Well, thank you, sir.
And it's, for me now, near 400 episodes. It's a big moment of reflection because I still remember doing episode 1. And just all of the things at that time that we thought we'd be doing with the show and where it's at now, it's a completely different entity. But some of those same original elements are still in the show and they're not going anywhere. So while we have a few things in mind, we're going to respect that heritage. We're going to keep you informed as we do that. We'll use this time of travel and whatnot to kind of work out our plans and all of that. So if we are gone, if we miss a few episodes, don't worry. We're working on things behind the scenes. And you can always grab every episode that gets published by going to techsnap.systems/subscribe.
You know, and that's it. Like that, to me, TechSNAP is the place where you can go to, to get complicated technical stories explained really well. And if you just want a rundown of the news, well, go to Linux Action News. There's a whole bunch of other great podcasts out there. And I think the space for TechSNAP is to just be the best explanation. And sometimes that takes a little longer.
That's true. Now, why don't we leave them with a few cool tools that we came across during our prep for this week's episode that didn't really fit at the top of the show, but we still want to talk about them.
Yeah, that's right. Okay, so as we said, WireGuard's not magic. It won't do everything that you want, but it is a really good, secure building block. And it is really amenable to automation because it doesn't try to do too much. It's not super complicated to use. It's not a big graphical application. So I thought we'd include a little things if you want to go start playing with it, but maybe you don't want to roll everything yourself. One aspect of WireGuard that's really great is just point-to-point links, right? That's at its core what it does. And so that's where I saw WireGuard Private Networking, which is just a simple little Ansible role to deploy a fast, secure, and provider-agnostic private network between servers. And actually, I saw this over because, some people are using some hosts that don't have private networking, encrypted networking between the various machines that you might spin up on their platform. This lets you use WireGuard to do that.
Oh, fascinating. Oh my gosh. I had not even thought of that. That has a lot of potential.
It really does.
Yeah, so this script that we'll have linked in the show notes is, I think, primarily focused for either Debian or Ubuntu, but under the surface, it's really just using some of the essentials in systemd. So even if you're on a CentOS box or something, you could probably take a look at this and see what it's doing.
Okay, and in that same vein, there's also Algo VPN, which is really it's a similar project. It's another set of Ansible scripts, but it is much more full-featured and aimed less at, building your own private infrastructure and more at just rolling out a custom VPN solution for you.
Yeah, and it has some nice helper scripts in there to add or remove users or set up local DNS resolving. You can set up some limited SSH users for handling certain types of traffic. So it's got things to make it easier. And this also loads on things like DigitalOcean, Amazon EC2, Azure, Google Cloud. So it's pretty flexible in that regard.
While we're hoping WireGuard just gets everywhere, for the moment, it's not. And Algo also sets up IPsec, which has handy native integrations in just about every commercial operating system out there. And not only that, if you've ever used IPsec, you know that it can take a little bit to get everything right. Like, how do I do key exchange and which version and what cipher should I use? Algo's made good, modern, safe, strong choices for you. So you can just, obviously audit it, check it, but their defaults are good.
Yeah, it's at least a good place to start. I think your advice to check whenever you're doing something like this in a real production situation, you got to check it yourself. But this is a great starting point, and linked up techsnap.system/390. I'm just going through the installation right now. It's actually not even that complicated. It's really easy to get going. Nice finds, Mr. West. Nice finds.
You know, these will probably be things, I'm thinking Algo in particular, that we may deploy for ourselves over on the Jupiter Broadcasting Network. So
It might just be
expect
it.
to hear more about that. Or, again, just let us know. Because sometimes the tools our audience finds are some of the most helpful things that we ever end up using. So if you've been playing with WireGuard or any other VPN technology and you have your favorite tools, let us know.
All right, well, let's get out of here. But first, I will mention the Twitter handles. I am at ChrisLAS. He is at Wes Payne.
Thank you so much for joining us, and we'll see you
Next week.